Alright, it's 5 past. It is not midweek with Max, like I was about to say, but I've been gone for 7 days, so hello. Welcome to the second or third Hemi Engineering AMA. I am joined by our crack team of engineers and our co-founder Max Sanchez, and because I don't have a lot to say on this subject matter, I am immediately going to turn it over to the gang, await questions, and then start asking them. So take it away, boys.
All right, awesome. Thanks everyone for showing up for the engineering AMA. So we got a bunch of questions people submitted, which we'll be going through. Before we kick that off, I just wanted to go around the group and let all of the protocol engineering team who decided to join this AMA introduce themselves real quick, and if there's anything they want to talk about what they're working on, interesting stuff in crypto ecosystem more broadly, anything they want to chat through, give them the floor to do that. So I'll start by passing it over to JCV. And you guys have seen, I think, everyone on this call before, but for some of these people, it may have been a while, and if you weren't at the last AMA, so we're going to be good to do another round of intros.
All right, cool. Yeah, so I'm JCV. I've talked at these before, but those who don't know me, I'm a very long-time crypto guy, worked on Bitcoin stuff and then Decred stuff, both with Marco a long time ago, and then working on Hemi since before it was Hemi. And still, these days, I'm spending a lot of my time worried about security and math. I guess pretty much sums up what I've been paying attention to the last couple weeks. And I don't know where my phone went, which is concerning me, but I'll worry about that after the AMA.
All right, and throw it over to Marco.
Hey all, I'm Marco Pierbu, very long-term blockchain developer. Been doing this for pretty much since the dawn of time. Worked on Bitcoin, Decred, various other things. I even want to say that I may have implemented the very, very first MVP of what ultimately became Hemi. It was called BVM at the time. So I think we did the first demo there, if I recall correctly, Max. And yeah, so I've been around the space for quite a while, and I pretty much work mostly on the core daemons that we use for Hemi.
Awesome. And Joshua, you're a familiar face to the community, of course, but anything you want to add about what you're working on, what kinds of things you're doing at Hemi, beyond helping Rick manage the community and write Discord bots?
I'm Joshua. I'm a software engineer on our protocol engineering team. I mostly work on our core daemons, but often end up helping Rick with Discord things, which is why you see me here a lot. Currently working more on infrastructure-related things and improvements to a lot of our services and daemons.
All right, awesome. And Antonio just joined, so we'll throw it over to him for a quick intro and what he's working on with Hemi.
Hey, I'm Antonio. I'm also one of the members of the protocol engineering team, and for most of the time I'm usually also working on the core daemons and the big rework we've been doing on them for the last few months.
All right, awesome. So before we turn over to Rick for circling through questions, just some sort of housekeeping question. If you want to ask any additional questions that you didn't post in the other channel, feel free to post them in the chat here. All questions should be technical in nature, questions about the architecture, future features, current features, how various parts of the stack work. Also, if people want to ask questions about game theory, incentive design, I'd lump that under technical, and all that's totally welcome as well. And with that, I will pass it over to Rick.
All right. Thank you, Max. I just want to go on record and say this is why I like you guys, because I feel like this is a troll. It's like, hey, let's get the meme guy to ask some of the smartest people on our team the most technical questions our community has to offer. So with that said, let's start with HVM. I'm going to do my best, gentlemen, to pronounce everything correctly. Feel free to roast me in the comments. How real-time is the Bitcoin state accessible by the HVM? The HVM, I apologize. I'm already flubbing.
Good question. So there's actually some interesting game theory and security details baked into this. So HVM runs at a 2-block delay versus the publicly known Bitcoin consensus tip. And the reason for that is in order for the EVM, for HVM to be able to process smart contracts that do HVM Bitcoin node calls, that data needs to be accessible for that full Bitcoin block that represents the current Bitcoin index state. And so if you always had it run at tip, there's a possible attack vector where somebody could mine a Bitcoin block and withhold it, so not propagate it publicly to Bitcoin peer-to-peer, but send that Bitcoin block header to the Hemi network, and that would cause HVM to try to index onto a Bitcoin chain that it doesn't have the data for, and it wouldn't be able to calculate the state transition correctly. So that's why we have a lag that's currently set to 2 Bitcoin blocks with HVM. So basically, if the current Bitcoin tip is block 1000, HVM's fully indexed state will represent block 998. Also, to add a little more color to that, there is a slight delay between data being public on Bitcoin and actually getting included in HVM's lightweight state view of Bitcoin consensus. And that's basically the time it takes a sequencer to observe the new Bitcoin block header and then create a Bitcoin attributes deposited transaction that brings that data into Hemi state awareness.
And let me add one other little bit to that. Strictly, there's no such thing as real-time data in Bitcoin or in any, proper blockchain. These are systems that are eventually consistent, which means what is the current tip? Literally, there's just what does the node you're talking to know as the current tip? There's no master state out there that has some real-time clock that is ticking away and everyone's following it. So, there's the 2-block delay from the sort of rough state of the network that Max talked about. But we have to remember there's just literally no such thing as real-time Bitcoin data. There's what your node knows and there's what view of the mempool you have. And that's kind of it. And that's as close to real-time, in whatever the scariest scare quotes you can put around it, exist in any proper blockchain.
Yeah, and also that sort of, you only have the view of the network that your node can see. On a similar topic, that's why we can't have HVM access mempool data because it's non-deterministic. And so if you had, say, an HVM query that said, get me the most expensive transaction in the mempool, that would potentially see different transactions on different Hemi nodes. And so that would return different information to the EVM depending on which node it's executing on. And then that would result in a state divergence. So you'd get node A that ran the smart contract and got this result, and node B that ran the same smart contract with the same inputs at the same block and got this different result because they have non-deterministic views of the mempool. So we do have mempool support in TBC, which is the tiny Bitcoin. It's the Bitcoin node that we custom built to be able to embed it inside the EVM. But that mempool feature is only for using TBC as a standalone Bitcoin node, for example, with pop mining with our new daemon refactor we're getting merged in, not for being able to get mempool data within the context of HVM smart contract execution.
Okay, thank you. I'm probably gonna need a cue. I gotta be honest. I'm gonna need a cue when.
Oh yeah, sorry. I kind of tend to trail off at the end of my sentences too. And it's not. You're not sure whether I'm delaying for some major point or I'm just done talking.
I didn't know if you're gonna come back. I feel like Billy Madison when he's in that debate, if that makes any sense to anyone. So.
So think of it as we've got like a 2 Hemi block delay between when engineers finish and when Rick picks up.
Yes.
Oh man.
Okay, let's move on to our second question. What is the typical latency between a transaction being confirmed on the Bitcoin L1 and a Hemi smart contract being able to verifiably read the transaction's state?
So basically, same answer as the first question. So that 2 Bitcoin block delay, that's the delay for the full Bitcoin node embedded in HVM to index that new Bitcoin block. And then once it indexes that new Bitcoin block, then those transactions would be available and you'd be able to verify them through HVM precompile calls. So short answer, 2 Bitcoin blocks, and that applies to any information about Bitcoin, whether that be transactions, the state of the UTXO table, UTXO being spent, anything like that. That all runs at that same 2-block delay because that's the delay of the indexer.
All right. Okay, here we go.
Sorry, I forgot the cue.
No, it's totally cool. I picked up on it that time. I caught on the 2-block delay. See? I'm learning, JCV. All right. What the? Okay. Hemi uses Bitcoin for settlement, but Ethereum for data availability. Can you explain the technical reasoning behind the choice versus attempting to post all data to Bitcoin?
Yeah, good question. So this gets into DA and just a little bit of background information. DA, or data availability, it's a common term you'll see in most L2 network designs where they have some solution for DA, whether that be Ethereum or Bitcoin or something like Celestia or EigenDA or whatever. And the point of DA is for an L2, you want to make sure that everyone can recreate the L2 state and do so in a way that's deterministic, and hopefully you're getting that data from a source that's never going to be able to lose that data. And there's a couple technical nuances there. For example, DA on Ethereum with EIP 4844 blobs, those do get rolled off by most nodes. They get pruned after about 18 days, but they're cryptographically verified to the block that they're contained in. So if you're running a node, you can basically archive those old blobs and prove that they're part of the block to help the new node that's bootstrapping. And also RPC providers, like QuickNode and the like, will cache or store all of the blob data historically on Ethereum. So that's the kind of the technical context for what DA is. And so the idea is if you have all of your blockchain's data published to Ethereum, then you will be able to recreate the entire blockchain state by reading data from the Ethereum chain. As for why we chose Ethereum versus Bitcoin for that, it really comes down primarily to scalability and cost. So Ethereum is very well optimized for DA, one of Ethereum's main roadmap items after they switched to a rollup-centric roadmap versus a sharding-centric roadmap. I think that changes back in late 22, early 23. They've been focused on building out and scaling Ethereum's DA feature with KZG commitments, all kinds of interesting things that make Ethereum a better place to use for DA in general. And obviously, it still hasn't scaled to the likes of Celestia or EigenDA, and those have their own trade-offs. But Ethereum's a good choice between cost and security, and the roadmap will continue to expand out that amount of available storage space for DA blobs in the future. Whereas Bitcoin is limited to, in the best of times, 4 megabytes per block. And so scaling with Bitcoin DA will be a lot more expensive, and all of the chains combined have to share that 4 megabyte every 10-minute block space. And obviously some of that's going to be used by transactions on Bitcoin itself. And so if we were to do DA on Ethereum, or on Bitcoin rather, it would be, during fee market spikes especially, it could be anywhere from 10 to 100 times more expensive, depending on how exactly it's done. And also, if a lot of L2s were to choose Bitcoin as a DA layer, that space would become even more crowded and get even more expensive. So it's mainly an issue of cost and scalability, but also Bitcoin's slower and unpredictable block timing also means that using Ethereum for DA gives you more consistent, pseudo finality from blockchain state being DA published.
But also, Hemi is a good citizen at Bitcoin. Like, we want to use Bitcoin, and we want Bitcoin to be usable for people, And so part of that is we're not going to try to grab every last bit of blockchain space that we can in Bitcoin when there's other alternatives that'll work just as well or better for us. We're good players in Bitcoin. We're, providing fees for miners. And a good number of us here on the call have already seen the Bitcoin community, with their torches and pitchforks out for us. And none of us need to repeat that.
Yep, and also adding on to that, the way that we try to approach Bitcoin is very value adding. So we want to make Bitcoin more powerful, more programmable, let people do more stuff with their Bitcoin assets, and consuming a lot of very precious Bitcoin block space for doing DA is, I'm personally of the mind that it's a permissionless protocol, and if you're willing to pay for the space, you can do whatever you want. But the reality is, L2s using Bitcoin for DA is going to take that space away from other use cases on Bitcoin that may be more valuable. And long term, that should be solved by people paying for the value that they get from publishing data to Bitcoin, whether that be a regular Bitcoin transaction or a blob of L2 data or whatever. But the reality is, using Ethereum for DA, that's partially what Ethereum is designed for. It's going to scale better, it's going to be cheaper, and you have better timing expectations. There's some applications of the timeliness of data getting DA published to Ethereum that are relevant for interoperability protocols, and having a unpredictable block time on the Bitcoin side has impacts there, which can slow cross-chain interoperability stuff down. But yeah, for tons of good reasons, we're using Ethereum for DA. And also the idea of using Bitcoin for DA is nothing new. It wasn't called DA back then. But if people remember protocols like Colored Coins, Mastercoin, which turned into Omni, or Counterparty, those were essentially, to varying degrees, blockchains that were embedded in Bitcoin. So they had more functionality, but all of their data was published to Bitcoin itself. And we've actually seen that scalability crisis play out with why, especially during fee spikes back in the day, protocols like Counterparty, Omni were often way too expensive to use to be practical. You'd be selling a 25-cent NFT and paying $1 worth of Bitcoin fees to publish that Counterparty transaction. So we've already seen that scalability limit be hit before with much more scaled down approaches in an ecosystem that had way fewer users and way fewer transaction demands. So we don't think it makes sense to try to repeat that experiment today.
And those fee spikes were at a radically different Bitcoin price point.
Yeah, the equivalent, I think some of those fees from the old days nowadays would be hundreds, potentially, of dollars. So not that we haven't seen that on Ethereum, but the separation of Ethereum of regular transactions versus DA kind of keeps that DA market isolated and protected to some extent.
I think we're kind of also papering over the fact that adding basically being Ethereum compatible opens up all kinds of interesting things, right? Being the premier contract platform.
Yeah, for sure. And that kind of plays into interoperability and just kind of following standards as well. Most L2s today that people are widely using, that people have integrated into a lot of different protocols, they use Ethereum for DA. It's a well understood setup for a lot of third-party tooling that you want a node operator to run a node of Hemi so they can provide third-party RPC services. They're familiar with using Ethereum for DA. They know how to monitor it. Whereas using for Bitcoin for DA, there's some L2s doing it. Some of the node providers have some understanding, but all of the infrastructure, tooling, monitoring that we have in the space that's very mature is based around primarily Ethereum L2 architectures, which use Ethereum for DA.
Okay.
All right, back to you, Rick.
Well, thank you, sir. I believe a lot of this was covered. And if it has been answered in full, please feel free to just say next question. But I noticed a lot of context clues. So, does the recent EIP-4844 blob space on Ethereum make this model significantly more cost-effective and scalable than any Bitcoin native DA solution?
Short answer, yes. So we kind of touched on that with the last question, but basically the history of Ethereum DA. So when chains like Optimism and Arbitrum were first being built, Ethereum didn't have what we call blobs. That's EIP-4844. And so in order to publish data to Ethereum, you did it in what's called call data, which is basically just shoving your data in an Ethereum transaction in a way that Ethereum, quote unquote, ignores the data. So it's not being used in a smart contract or anything like that, but the data is still getting published to Ethereum. And so those L2s were competing in the same fee market as regular Ethereum transactions. So if there was a ton of people who wanted to play CryptoKitties, that would impact the cost of your DA because you're competing with those users for that same space. And then with EIP 4844, the amount of space got expanded. So the total volume of data that could be published to Ethereum every 12 seconds increased, but also it got separated out into a different fee market. And so, CryptoKitties can explode and people can be paying, 100 gigaway per unit of gas. But if there's not a ton of demand for blob space, then blobs will still be cheap. So it makes sense from an economics perspective to separate those two out, and also to say L2s have a different use case of data on chain than most other users. If you send a regular Ethereum transaction, you want that transaction to stay in the chain forever and always be available and for all nodes to save it. Whereas for L2 data or blob data for an L2, you can very easily say, this data only needs to be retained for about 2 weeks or so, and then most nodes can prune it. It's not needed to verify EVM execution in the future, so you don't need it to sync a full node from scratch, for example. It's just kind of sidecar data that gets included alongside blocks. And so it was not only just the expansion of the amount of data available, but the separation of that into a fee market and pruning mechanics that make more sense for the data demands of L2s versus the previous call data approach. Versus on the Bitcoin side, it's basically the equivalent of call data still, where anything published to Bitcoin gets stored on Bitcoin forever, which is good in most cases, but doesn't make economic sense for a DA system. And also you're competing directly with all other use cases of Bitcoin, just like the old call data DA model on Ethereum was competing with all other users of Ethereum itself.
Okay, thank you, sir. All right, for developers building Bitcoin native dApps with the HVM, what does the smart contract interface for reading L1 state look like? And are you implementing precompiles or opcodes? I ask myself that question every day.
Another good question. So the interface, so if you're developing a Bitcoin native, quote unquote, Bitcoin native DeFi app using HVM, you're going to be talking to precompiles, either directly or indirectly. And so to differentiate opcodes from precompiles, opcodes are opcodes that run inside the EVM. It's kind of a recursive definition, but they are, things like add these two numbers together, move this memory or move what's stored in this register to this register. And so very low level, when you compile a program, like say you compile opgeth, that's getting compiled into opcodes that run on your CPU. And so, x86 64 architecture or ARM or RISC-V or whatever you're using, you basically take high level languages and you compile it down to code that the machine can understand. And so opcodes in EVM are those low level machine instructions that the EVM is built to support and be able to execute. Precompiles are something totally different. And so you could theoretically add an opcode. You could implement HVM by adding opcodes, but it's not the ideal way to do it, because Ethereum has this other thing called precompiles, which let you step outside of the current EVM execution context and get data from just regular, Go code or Rust code, depending on what language your implementation of the Ethereum execution layer is implemented in. But it's able to step outside EVM execution, do something in that, Go code or whatever, and then return that result back into the EVM. So on the Ethereum side, precompiles are usually used, or pretty much solely used for accelerating a bunch of cryptographic functions. So being able to, say, verify, calculate the SHA-256 or SHA-3 hash of some data. If you were to implement those directly in EVM opcodes, it'd be very expensive. But because we can step outside the EVM and run some known code that's written in Geth or Rust or whatever, those things can be a lot more gas efficient because we're not compiling all those very complex algorithms into EVM bytecode. And so we were able to extend that precompile system to use that same, stepping outside the EVM execution to be able to then talk to that Bitcoin full node that's embedded inside of, in our case, opgeth. And so when you call, the SHA-256 precompile, it runs some Go code that calculates the SHA-256 hash of input data. Similarly, if you call one of the HVM precompiles, you're sending it serialized data that reflects what request you're making. So for example, I'm going to call the UTXO's precompile with this number of items for this script hash, and I want, 5 items per page, and I want the third page of UTXOs. And then what happens is the EVM it'll step outside the EVM execution, it'll deserialize that data, it will make the appropriate queries against TBC, which itself has deterministic state due to how we integrated TBC into the EVM with deterministic state progression with the Bitcoin attributes deposited transactions. It'll complete that query on the TBC side. This is all just Go code that's running, and then we'll take the result of that, reserialize it, and return it into the EVM. And then EVM execution resumes with that new data passed back to the smart contract. And as far as from a practical sense, that's the low level for how it works, but most people are not going to be interacting directly with the HVM precompiles. That'd be, kind of equivalent in some ways to writing your program in assembly. You can definitely do it, and there's sometimes good reasons to do it for optimization, but most people would use some higher level abstraction, and so that's what Bitcoin Kit does. So Bitcoin Kit wraps around those low level precompiles and makes it easy for developers to call higher level functions, things like, you can call get UTXOs and just pass in the script hash, the page and the number of items per page. It will serialize and do everything it needs to interact with the HVM precompile on your behalf. And then when it gets that data back, it'll deserialize it into easy to use structures that then you can use directly in your code. So HVM precompiles are the very low level, bare metal interaction between smart contracts and queries against TBC full node state. And then Bitcoin Kit sits on top of those as an abstraction layer to make it easier for people to use.
All right. Thank you. Okay, here is a multi-part question. How does the HVM handle Bitcoin L1 reorgs? If a Hemi smart contract executes a function based on observing a Bitcoin transaction, e.g., issuing a loan, what happens if the transaction is subsequently reorganized out of the Bitcoin chain? And is there a built-in confirmation delay that DApp developers must adhere to? And how does the protocol ensure state consistency between the two chains in the face of L1 finality ambiguity? I can repeat that if you want, because I feel like I need to repeat that.
I think I got most of it. So, good question. High level is basically what happens if there's a Bitcoin reorg. So there's two parts to this. The first is because HVM does run at that 2 Bitcoin block delay, any Bitcoin reorg shorter than that 2 block waiting period would not matter, because apps that are reading Bitcoin data with HVM would not even be aware of the original state that got reorged off, because the reorg happened before the indexer caught up to the block that eventually did get reorged. For longer reorgs, HVM will gracefully handle them, but your DApp needs to be built to observe that reorg or have a long enough confirmation internally for doing certain actions that are irreversible that a Bitcoin reorg would affect. So it's really up to the DApp developers. The minimum confirmations for anything you can do is 2, because that's how long you have to wait to get that information. So that's sort of a first line of defense. But DApp developers should wait additional confirmations for things that are irreversible. And so, for example, a DApp that just observes that somebody published a hash of some data they want to prove ownership of, that doesn't need to wait for additional confirmations in most cases. If, you're issuing somebody a license to do something with that data or whatever, you could just reissue it after the reorg when the data appears again on Bitcoin. But for something that's more mission critical, like, you issued a loan, or take, for example, the Bitcoin tunnel system, you've confirmed a Bitcoin deposit and issued the Hemi BTC on chain. Those things should be built with higher Bitcoin delays. So not just do you see the data, but is the data in a block that's more than 2 or 4 or 6 Bitcoin blocks behind the current canonical tip. So that's up to DApp developers. Again, everyone's forced to wait at least 2 Bitcoin blocks just because of the architecture, but DApps doing more important stuff should wait longer. And this is an important clarification with L2 architectures. So generally speaking, L2s, when they're just in a single ecosystem, like it's a Bitcoin L2 or an Ethereum L2, especially if they're using that underlying chain for DA, they will usually reorg with that chain. But in Hemi's case, since we're talking to multiple different chains, instead we don't reorg the Hemi chain. If Bitcoin experiences a reorg, we just reflect that reorg in the new index state that the Bitcoin indexer updates to, and it's up to dApps to set appropriate thresholds for confirmations that are enough that their app is secure based on the particular use case of their dApp.
All right. Thank you, sir. Okay. I am working on an on-chain lottery system, and I would like to generate random data to choose winners. Currently, Pyth or Pyth and Redstone don't support VRF. Are there any plans to onboard oracles to support this function?
We have talked with one Oracle provider, actually I think two Oracle providers, about adding VRF, so it is something we're looking into and want to eventually get support for. I don't have an ETA on that. That being said, there's also, depending on how your app works, there are also interesting ways to use Bitcoin block hashes as randomness, and there's various things you have to take into account. Obviously, since HVM runs at that delay, you can't just write an app that says the next Bitcoin block we observe will feed the hash of it into a random number generator and then use that, because people could peek ahead and see what Bitcoin blocks are coming. But if it's more of a slow rolling protocol, you could have the lottery close at noon and then say, okay, we'll wait 6 Bitcoin blocks and then use the hash of that as entropy into PRNG and then use that to select a winner. So two answers. One, yes, we are working on getting at least one Oracle to support VRFs, but also two, for some applications, Bitcoin block hashes can be used as a really good source of uninfluenceable randomness as well.
Yeah, anything you can do without an oracle is usually a good idea, if possible. Just from a general, blockchain design perspective. If you go look at, the history of exploits in this space, and, look, I feel good about any oracles we have, but still, if you can do things with on-chain data somehow, and there's always, there's all sorts of interesting things in Bitcoin blocks for seeding pseudo-random numbers. Definitely roll that way if you can.
All right. Thank you, gentlemen. Okay, we are moving on from HVM into node operating. What is TBC, and how does it work inside the Hemi opgeth node?
Good question. So TBC, it's our tiny Bitcoin. It's basically a custom Bitcoin full node that's been specifically designed to be able to be embedded in an EVM. And so what that means, a couple different things on the architecture side. And Marco did tons of work on implementing TBC along with the rest of the team. So Marco might have some good insights to add here as well. But basically, you can think of TBC as a Bitcoin full node that can be progressed deterministically. So TBC interacts with the Bitcoin peer-to-peer network to get Bitcoin data. So when you spin up an instance of opgeth, there are actually two instances of TBC running inside that, running in different modes. So there's a header-only mode and a full mode, or a fully indexed node mode. It's not great wording, but so the lightweight TBC node is used just for consensus tracking. And so when a sequencer produces a new block, a new Hemi block, if they observe new Bitcoin consensus information, a la new Bitcoin headers that are not yet known by the Hemi protocol, they will package those into a Bitcoin attributes deposited transaction, which parallels the regular attributes deposited transaction from Ethereum that brings some context about the current Ethereum consensus state into the L2 protocol. But they'll package the Bitcoin headers into that transaction. And then when other nodes on the network process that block, they will update their lightweight HVM state based on the new consensus information about Bitcoin that's contained in that Bitcoin attributes deposited transaction. And then from that, if that new consensus information extends the current canonical chain or results in a reorg that changes the current canonical chain, then the TBC full node state will be updated. So basically, opgeth will instruct TBC, and it'll say, hey, we now see, we were at Bitcoin block 999 before, and the full node is at block 997, that 2-block delay. Now we see Bitcoin block 1000 come in. We have the header for that. We added that to the lightweight consensus node. and it extended the current canonical tip to this block 1000. So therefore, TBC full node, you need to index up to block 998, which, to be more pedantic because there can be forks and stuff, opgeth will process the new header information with that lightweight TBC node, see what the new current Bitcoin tip is, walk 2 blocks behind that, and then tell the TBC full node to index to that block identified by hash, so not by number, that's just for illustrative purposes. And then TBC, from an architecture perspective, the full node mode for TBC directly peers with the Bitcoin peer-to-peer network, so that's how it hears about new Bitcoin data. And so we're not publishing, the full 4 megabyte Bitcoin block to Ethereum DA. Instead, all that's getting published is the Bitcoin block headers that carry that new consensus information that then deterministically decide what tip the TBC full node should be indexed up to, and it's indexing from Bitcoin data that it receives over the Bitcoin peer-to-peer network. So it participates in Bitcoin peer-to-peer, but it's driven deterministically. So it has, TBC will download new Bitcoin blocks whenever it hears about them on the network, but it won't actually progress into indexing them and reflecting its view of the UTXO table and transactions that have been seen and their association with the blocks they're contained in, all of that, until opgeth instructs it to update its view deterministically based on the updated lightweight view that was derived from information that's actually carried in the Hemi blockchain.
And one other fun little bit is, the first the second Bitcoin client ever written after the Satoshi one, or the second complete one, was BTCD, which, Marco and myself worked on very heavily back in, 2013 or something. And then Marco went and did. And so Marco did, probably a lot or even most of TBC. So you've got you've got some old school Bitcoin client writing coming back into a very new modern way, which is kind of cool because BTCD is some truly deeply ancient looking Go in a lot of terrible ways. So it's kind of fun to see it, some things be revisited in the modern world, when dinosaurs don't roam the earth anymore.
It's also significantly smaller. Let me do a quick grep just to get an idea, or a word count to see how many lines it is versus the other one. Hey, 1 second.
See, this is when we need the hold music that I've been pitching for midweek with Max. This would be a perfect time to start playing like Spanish Flea or something like that.
14,000. It didn't take that long. I can Unix.
What was the number?
About 14,000. For the including test
Bitcoin
code.
D.
Yeah, for TBC. Bitcoin D was hundreds of thousands of lines of code.
Oh, that's what I'm saying. Compare the difference between those two.
But in BTCD's defense, we do use some packages. We use the wire package, for example, which is very well written to handle the low level encoding and decoding of Bitcoin P2P messages. So those are that's a very helpful package that was written back then that did not have to change. But specifically, what actually was painful in the BTCD code is a lot of channel use. Which at the time was the modern way of writing code. That has been surpassed by using contexts, and using context is just so much nicer. So so we basically rubbed some new sauce on it, also to make it go vroom vroom, and use newer, Go things that just make it go a little bit faster, and it's a little bit less painful to look at.
Yeah, a lot of great old code we were able to reuse, and some maintenance and tune-ups that needed to be done.
Oh, and soon we'll have testnet 4 as well.
We're working on testnet 4 support. Yeah, I may have mentioned this in a previous midweek with Max, I don't remember, but we're testnet 3, as many of you are familiar, especially if you were with us back in the painful early testnet days. Bitcoin testnet 3 has a issue with difficulty calculation. It's a feature and a bug. It was originally the original developers assumed that there might be long periods of time where people were not mining on Bitcoin testnet because it is a test network. It's supposed to not have any value. It's just for testing. And so they introduced a rule that if there, I forget the exact details, but I think if there's not a block within 20 minutes, you're allowed to mine a minimum difficulty block. And normally that'd be fine. But what they didn't realize is if that happens twice in a row, the algorithm for calculating the Bitcoin difficulty target looks back 2 blocks to decide what the difficulty is for the new block, unless you're over a recalculation boundary every 2016 blocks. And so if you had 2 of those min difficulty blocks in a row, that algorithm would see, oh, our current block's min difficulty, the previous one was min difficulty, therefore the next block should be min difficulty, and then people can create tens of thousands of blocks in a day before the algorithm eventually retargets, and then we get 2 more min difficulty blocks and the whole thing starts over. And so that caused a lot of problems on our side for just the performance of having to process 100 times plus more Bitcoin data than anything was designed to do. But also, even after we resolved most of those performance issues, it still affects being able to write and test DApps on chain. Because if you're writing a DApp for, say, a Bitcoin lending market, on mainnet, you're expecting there's going to be Bitcoin block every 10 minutes or so, and you're not going to see any extremely huge reorgs. But if you're developing on testnet, on Hemi's testnet, which currently uses Bitcoin testnet 3, you might have to deal with tons of Bitcoin blocks coming in at once, and also potentially large reorgs of that happening, which your DApp shouldn't have to deal with because that's not reflective of what actually happens on mainnet. And so it makes developing HVM apps and prototyping them on testnet very difficult, especially depending on what type of DApp you're developing. But so moving over to testnet 4 will make the Hemi testnet be much more reflective of the real world realities of how HVM behaves in a mainnet environment.
And the price of testnet 3 tokens, as perverse as that sentence is, got very high.
Well, and there's the other.
For.
Yeah, so you can also download all of testnet 4 in about half an hour versus a day. There's also that.
Yep, yeah, it makes syncing a new node easier, and that'll have knock-on effects for anyone who wants to run any testnet node. Right now, it has to download and index for over 4 million blocks. I'm not sure if we may have crossed the 5 million boundary at this point. That's a lot of data to process just to get a node spun up for testnet. And on testnet 4, since it's a new network, you can download and index all of it in hours instead of days, which is great.
Okay. Thank you, gentlemen. All right. Where the hell are we? Here we go. What is being done to make setting up, operating, and monitoring nodes on Hemi easier?
Good question. And some of the people on this team have worked on some things like Prometheus, getting that embedded into daemons for better monitoring as well. So feel free to chime in on this question. High level, we did add Prometheus. We're adding more stuff to Prometheus. And so you'd be able to monitor for all the different daemons. Is it running? What's its current state? If it's say opgeth, what's the current block height? And so we are still working on finalizing some of that on the opgeth and optimism side. I believe some of that's actually sitting in a PR right now, and then there's some additional work to do to add more information to it. The Hemi network sort of quote-unquote core daemons, everything in the Hemi network repo, that's BFG, BSS, the pop miner, TBC, those all have Prometheus pretty well integrated already, and that can be used for monitoring. Marco just posted an example of running the curl command to pull some current monitoring metrics from TBC. And we'll have an equivalent thing coming into opgeth and opnode as well in the future.
I'd also say that PR 396, the big BFG thing, is very much related to making the stuff easier to run.
Oh, and also one other thing to add on to that, I think, John, you wrote this script, right? There's a script in local node. So if you're running our daemons in local node with sort of the default Docker configuration, everything, there is a script in there that does some lightweight node monitoring as well.
Yes, that is that Tmux thingy that I wrote makes it kind of easy for very simple monitoring, but at least gives you a sense for what you can be looking at and should be looking at.
All right. The HVMs. Should this have been in the HVM? Well, you know what? We're doing it live, baby. We're back to HVMs. The HVM's ability to read native Bitcoin state is a game changer. However, this requires that Hemi nodes must maintain or access the growing state of the Bitcoin UTXO set. How do you plan to manage this significant state bloat over the long term?
That's a good question. So the short answer is Bitcoin's UTXO table is not actually that big, and it's actually not growing that quickly either. There's actually been, I forgot whose blog it was, one of the Bitcoin developers a couple years ago did a really good blog post on UTXO growth trends over time. And there's actually been periods where the UTXO table shrank significantly because people took advantage of low fees and did a lot of UTXO consolidation. Short answer is the UTXO state, which is kind of Bitcoin's equivalent to the EVM state tree in a very, very high level analogy sense. And Ethereum state tree today is way larger than Bitcoin's UTXO table. And so the cost of storing it, processing it, updating it on the UTXO side is actually a lot smaller than EVM chains that get a lot of adoption. What they're seeing as the state tree size for their equivalent of the UTXO table. So Bitcoin's not really the bottleneck there. It's really more EVM state. If Hemi gets tons of adoption in the future and we're operating at Ethereum levels of DF deployments and transactions, our state tree is going to be way larger than the Bitcoin UTXO table we're tracking. Also, the way TBC is designed, its UTXO table is stored very efficiently. It's very efficient to update it. And there's some recent optimizations for the UTXO unwinder as well, which is a more expensive operation. They're not merged into opgeth yet, but those are coming that'll make unwinds on that UTXO table more efficient as well.
So also go look at the price of a mid-level SSD on Amazon, and if you were to plot that versus time, Bitcoin state is growing slower than that. Ethereum state has grown way, way, way the hell faster than that. So Bitcoin state doesn't worry me at all. Ethereum state, as somebody who used to run Ethereum archive nodes, that one's a bit more of a killer.
Yeah, I think what's an Ethereum archive node up to now? Like 3 terabytes?
Oh, that's cute, Max. We were running, I think, 13 or 14 terabyte nodes prior to Hemi.
Oh my god.
So what it's up to now, I don't even want to think about. All I know is those nodes were. I have definitely been responsible for sending AWS a lot of money for disk usage. A lot of money.
Yeah, Ethereum state growth is crazy.
And I'm proud. At least one of my Ethereum archive nodes killed more than one physical disk at AWS. So that managed to hurt both me and the other people using the same hardware. So
the joys of cloud computing.
All right.
But yeah, high level, basically UTXO table. I want to say right now the UTXO table, if you compress it and store it efficiently, is somewhere in the 2 to 3 gigabyte range. The Bitcoin.
27. I pasted the numbers, Max.
Oh, 27.
Transactions is the ugly one, and blocks is about 400 something.
Yeah, blocks is huge. I think there's other stuff in our outputs table for indexing though that's beyond just the size of the actual UTXO table serialized.
I'll paste the whole thing so everybody can see exactly what's going on. It's the majority sitting in blocks and transactions, and the rest is kind of peanuts compared to it.
And also from a data structure perspective, the UTXO table is super efficient to query as long as you have it indexed correctly, because it's just basically looking up hashes in a hash table. So.
Okay, I have a follow-up to that question. Follow-up to the previous. How does this design decision align with or diverge from Ethereum's long-term roadmap towards stateless clients and Verkle trees?
Good question. So, and this is in reference to the previous question, right, about the Bitcoin UTXO table size.
It just said a follow-up to the previous question in the notations. So,
Okay, I'm going to assume that's the case.
or we just assume it's a standalone question.
So basically, obviously with Hemi having an embedded Bitcoin node, we're adding extra data versus not having an embedded Bitcoin node. The main thing for light client support will be ZK provability, at least on our side. And so once we have ZK provability for TBC itself, and that integrated more broadly into ZK provability for the optimism stack, and with our modifications to it, that'll let anyone run light clients very efficiently. So basically, you'll be able to get a ZK proof that, since September 9th, 2024, or I may have the mainnet date launch date wrong, because I think we did 2 deployments, a test run and a full run. But anyway, since whenever Hemi mainnet started, here's a proof that Ethereum state looks like this, that all of the Hemi DA extracted from that Ethereum state up to that tip looks like this, that processing it through Hemi's block derivation protocol results in these L2 blocks. You can also have ZK proofs in there for POP consensus, and those would be also have ZK proofs of TBC state transitions and TBC queries. So anytime that a smart contract calls one of the HVM precompiles, that in a ZK proving context could be replaced with a ZK proof of the return result of that query based on HVM global state at that point in time. So short answer for light client support on our side, that's going to be very ZK driven. As for how it fits into future Ethereum changes to state, we'll be adopting those changes into how we serialize our EVM or HVM state tree. But TBC is a totally different component with its own data architecture. And that's required because Bitcoin's fundamentally a much different protocol. And so, for example, Bitcoin by default does not have the UTXO table lined up in a Merkle-Patricia radix tree. And so it's a different animal, and you can convert one to another. And for ZK provability, we'll be doing some of that, but they'll remain different data structures with different data serialization, different ways to access that are indexed and optimized for the HVM queries that we want to support on that Bitcoin data set.
All right, thank you very much. How does a validator node work on Hemi?
So in the future, when we launch decentralized sequencing, a validator node is going to behave very similar to a validator node on Ethereum. So basically, you'll stake Hemi tokens, you'll run a node in some sort of validator mode that knows about your staked position and follows the consensus protocol to decide when it's your turn to produce a block or when it's your turn to vote on finalizing existing blocks. So if you're familiar with running a validator on Ethereum, the actual technical steps will be a bit different, but it's the same general idea. You're going to stake Hemi tokens, run a node that's aware of that stake position, and then it's going to participate in consensus, both creating blocks and voting on blocks to mark as safe and finalized as part of the overall consensus protocol.
All right. Gentlemen, we have entered a new category. It's open source. How are you working on improving your release process in order to make node operation easier by providing detailed changelogs, stable releases, and more?
That's a good question, and I think we addressed this a bit on Midweek with Max yesterday. We definitely we are planning to get into a more formal release process, and so you will be seeing that process formalize in the near future. A lot of development up to this point has been racing to get features in, racing to mainnet and then racing to the Pectra upgrade. But now that Pectra is behind us and we're working on more long-term features, starting with breaking ground on code for ZK provability soon. A bit after that, decentralized sequencing. It is definitely time to shift to a more formal release schedule. And we also have a lot of people running nodes now, and not just running nodes for fun, but running them in production to support DApps and analytics dashboards and even maybe custom explorers, things like that. And so we will be formalizing both the release process itself, but also any breaking changes communicating that through common channels where people who are running nodes can monitor all that.
And I think actually the big one here is also 396. So we keep talking about it, but 396 is the PR, giant PR that Joshua has been painstakingly be peeling apart because it was so big to get it committed. But that is a refactor of all the daemons. And it's actually the PR where we paid our technical debt that we incurred during initial development. So for all the right reasons, we stuffed way too much in BFG. And that had as a side effect that it basically sat in the middle of everything and did way too much, but it didn't belong there. So it's all solved in 396. It's going to be much more streamlined, but yeah, but that's going to be once that bear is in. I think not the only thing that we should switch to a much more formal release schedule and mechanism that also will make Josh quite a bit happier.
Well, I fully support it if it makes Josh happier, because that works for me. All right. Oh, wow. Okay. One more for open source, and then we're moving on to security. And then we have 5 more categories. Wow, we got a lot of questions for this. This is great. Okay. What were the motivations for the work-in-progress pop miner rewrite?
A lot of different things. So Marco already touched on BFG sort of being in places where it shouldn't have been, acting as a middleman between a bunch of different pieces of our infrastructure. So a big part of the rewrite is taking that out and making the pop miner be able to run connected to any sort of Bitcoin RPC interface, starting with TBC. There's also some improvements in there that with TBC and mempool management, people could extend the pop miner to do interesting things with mempool statistics for fee calculation much more easily, although that would require custom work. But the big thing was, as Marco said, cleaning up technical debt, getting BFG to be in the right place in the stack rather than the sort of catch-all intermediary, and making it easier for people doing custom work with pop miners to have access to the data they need to implement those custom features, and also just a cleaner code base to work with. I don't know if Marco, Joshua, Antonio, you wanted to add anything else into that for the pop miner refactor?
I'm actually looking for the diagram that we drew that I'm going to paste here as a picture. So because it's very interesting to see what it looks like today. Hang on, I'm just clicking a couple of things. Nearly there. Because it really did make life quite a bit simpler, and we were doing things just way too complicated. So, and now we have, if I can only find my tabs open, you cannot find your thing again. Oh, somebody already beat me to it. Yes, what Joshua said. So as you guys can see, that this is quite a bit of a different approach. So first of all, we removed BSS. We had some big plans for it in the initial design, but it turned out to actually not quite be the right decision, and it would require some reach arounds that would be a violation, so a layered violation. So we decided to remove it. And as you guys can see, there's now no circular dependencies. Basically, everything lives in its own little world, and they do talk to one another, but not around one another, which is what we did initially with BFG. As part of this PR, that may not be obvious, a lot of additional things were also added, like fee calculations, which we didn't have. That was all static. So there's a huge amount of tiny little changes that are going to be very different, and is going to even change the entire stack and how to set up the network. So, and again, so once 396 is in, we can move to a much more formal development schedule and releases, so that we don't just drop 20,000 lines of code on people. But this one was just needed in one go. I tried to do it in pieces, and it just couldn't be done. It was just too many moving pieces that were touching one another, and so I did I basically deleted the code and copy and pasted back what I needed, and wrote the whole thing from scratch.
All right.
It was a huge refactor. It's been months, I think, now in the making to get all that cleaned up, clean up the technical debt, re-architect the whole stack, what talks to what. So tons of work went into 396, which we will be merging in the very near future.
Yeah, but the important thing actually that I think actually that we are not really mentioning here is that now the determining finality is really simple. Now calculating fees is really simple. So hard to read code that was doing odd things is now very much contained, and the majority of the PR is really cleaning up just stuff, and the things that really matter are now nicely tucked away where they belong, and they're much more readable. And to me, that's a huge win.
Okay, thank you for that, gentlemen. The category is security. I don't know why I made that sound like Jeopardy. It would be a lot. We should do a Jeopardy with some of these at some point. Okay. How often will Hemi's smart contracts be audited?
Short answer is anytime there's a major update to them. So, for example, we are working or are going to start working on soon an update to the current Bitcoin tunnel design that adds some additional features. Long story short, there was a issue with some wallets that claim to support the Unisat interface but don't. People on the app UI front end, if they were using one of those wallets that basically pretends to be Unisat but doesn't support op returns. There's some issues with people constructing bad deposit transactions. I think there were only a total of 2 or 3 of those, but we are going to be making some changes to the Bitcoin tunnel smart contracts that change that deposit flow a little bit. So any changes like that, whenever those happen to any of our core smart contracts, that will be time for a re-audit. A lot of the code that we're using on the Ethereum settlement side comes from Optimism and is already audited. But if we which we will be making changes to those in the future, we'll be auditing those changes. So for example, when we get ZK provability of Hemi and we update the settlement contracts on Ethereum to use those ZK proofs, we would of course be getting those changes to those contracts audited. As for the code base, we did go through an audit right before mainnet, or maybe it completed shortly after mainnet release, but we did a code base audit with HackerOne, and that is something that we would like to increase the both the scope and the frequency of in the future for major releases. I don't know if anyone else wants to chime in on that. A lot of Hemi's code is not smart contract stuff, and so auditing is a little bit of a different animal. It's checking to make sure that changes you made to opt-get, for example, don't introduce security issues, don't introduce race conditions, things that could potentially crash a node. And so it's a very different animal than auditing smart contracts, but you've got to do both of those, and we've done a lot of auditing on the smart contract side, and we've also done that HackerOne codebase audit, and we'll be expanding that in the future.
Okay, moving on to our next question. What are Hemi's future goals for improving the security of the network and its infrastructure?
Kind of an open-ended question. It's just a continual iterative process of doing pen testing, putting out bug bounties for people who do find issues and report them through responsible disclosure mechanisms, continually checking how we're running our infrastructure, making sure it's going through best practices. It's a timely question. We have a call this afternoon for a bunch of hardening and going through basically some NSA and DoD papers for hardening various tools that we're using in our infrastructure. So that's another layer of just continually iteratively improving security on the infrastructure side. And then on the network side, that's really more about good code, making sure code's well written, code's audited, code's well tested before being deployed.
Okay, moving on. I believe we are still in security. Yes, we are. How is Hemi encouraging responsible disclosure of security vulnerabilities?
I'm going to hand that one over to John and Joshua because they're much more on the front lines of the bug bounty program.
Yeah, in a sense, we're encouraging it by doing a bug bounty with HackerOne and, just following the industry standards with that. because this is one case where the industry standards are good, just not everyone follows them. So we've got a bug bounty program. You participate in that, and at that point, yeah, Joshua has the link for it, and that way responsible disclosure happens in the way prescribed by the program. So it's very nice because that way it's not, there's no one-off crap or anything of people, hoping or anything like that. You do it through there, we deal with it through there, we disclose the way you're supposed to on HackerOne. It's nice and orderly, which for responsible disclosure, orderly is what you want. And Marco, that is a very good point. You missed the probably best named things in this entire industry.
For the security programs we have too, there's a private bug bounty program that we are running with HackerOne. We invite people who have a good reputation on HackerOne and sometimes people who report good findings via our vulnerability disclosure program. We also have the vulnerability disclosure program, which is basically see something, say something. It's not, we don't generally issue bounties except for very high severity reports, but we do have two programs.
All right. I have a pop mining question. When a pop transaction is published to Bitcoin, what information is included in that transaction?
So right now that it's, I believe, 73 bytes of data, and it's essentially a Hemi blockchain header. So that contains basically positioning information in that block. So what's the block's state root hash, so what data is actually included in the block, but also what's its immediately previous block, previous keystone, and the L1 and L2 block numbers. So the L1 Ethereum block number that Hemi header was derived from, and then the block number of that Hemi block on the L2 itself. In the future, right now that fits into an op return. Op returns are limited to 80 bytes. In the future, when we introduce decentralized sequencing, that amount of data will expand because we will need to publish some additional information that basically proves that the sequencer who produced or the validator who produced that block was permitted to produce that block at that time, and we'll also have votes on safe and finalized blocks in a compressed format published there as well. And so that change, since it is going to require more data, that's going to have to be done through a SegWit commit reveal, kind of similar to how you publish a bunch of data to Bitcoin for, say, minting an ordinals NFT. So right now, it's just basically a Hemi blockchain header with a tiny bit of additional data, but in the future, that will be expanded to support decentralized consensus to be able to validate the validity or potential validity of that block in Hemi's proof of stake system. I'll also add on to that, and this will be part of the upcoming HBitVM white paper when we finally finish internal review and I finish one more section and we can get that published. There's a addition that we can add to it, so it may not be part of V1. Maybe part of V1 for HBitVM, maybe part of a V2 version of the protocol. But there's some really cool stuff we can do by publishing some Ethereum consensus data to Bitcoin. And so, Hemi's mantra is take the best parts of Bitcoin, the best parts of Ethereum, and combine them in a way that creates a whole where the value is greater than the sum of its parts. And for most of the projects that are developing BitVM derivative technologies, they're over on just the Bitcoin L2 side. They're not touching the Ethereum ecosystem, or if they are, they have interoperability through like layer 0 or something. But they don't have native protocol integration on the Ethereum side. And with their BitVM designs, they're looking at just what can we do being an L2 on Bitcoin? How do we build this very safe, very capital efficient bridging mechanism from Bitcoin to the L2? And with Hemi's unique position being between Bitcoin and Ethereum, there's a lot of cool stuff we can do that improves BitVM security and capital efficiency by using both networks together and sort of against each other to keep each other in check. And so we can dive more into the details. This could probably be a whole separate AMA on just BitVM once we get the paper published. But there's some really cool stuff you can do with publishing Ethereum consensus proofs to Bitcoin. And you kind of have this audit trail, this public audit trail of Ethereum consensus embedded in the Bitcoin protocol. And so in the future, when we do implement that feature, whether that's BitVM v1 or v2, that would also add additional data that gets published through the POP publication process to Bitcoin. But the economics of it are slightly different. So there would still be publishing regular Hemi consensus state data to Bitcoin, whether that be the headers as they are today or the future headers plus some additional consensus information for validating primary block validity in a proof of stake protocol for Hemi's own native proof of stake in the future. But we'd also have a separate track where people are publishing those Ethereum state consensus proofs to Bitcoin. And there's ways where you can use that to basically create a ZK prudent state of Ethereum that can't be forged by somebody doing a nothing at stake attack. And so I know I'm getting way into the weeds on this question, but with if people are familiar with proof of stake protocols in general, there's something called a nothing at stake attack, which is where people with a bunch of old validator keys who are no longer actively staked can go and produce an equally valid looking chain from a far back point in the past, a year, 2 years, 3 years ago. And so normally that's only really a risk to new nodes that are bootstrapping with the network. So you could confuse, a new node syncing from scratch that the actual Ethereum state looks like this, which is this malicious nothing at stake attack chain versus a legitimate chain. But when you get into the ZK proving context, we're sort of coining the term ZK NAS, ZK nothing at stake attacks, which are because of the zero knowledge property, because you're not revealing, which validators were actively creating this malicious fork, which ones voted in attestations to finalize blocks in that fork. Somebody even with recent staking power that is still at risk can produce and fake out ZK verifications of Ethereum consensus without revealing the information required to actually slash them correctly. And so by taking that information and publishing that from Ethereum to Bitcoin, basically in a public form, we can make it so ZK proofs of Ethereum state and thus Hemi state as well, because Hemi state's derived from DA from Ethereum, that ZK proofs of that could not be falsely created by nothing at stake attackers on Ethereum who normally would get slashed for doing a shorter range, quote unquote, nothing at stake attack if they were reorganizing the actual Ethereum chain publicly, because they'd be revealing the data needed to slash them, whereas in the ZK context, that data is not revealed. So this is a way that we can leverage Bitcoin to make ZK proofs of Ethereum state secure against that ZK NAS class of attack vectors. That went way off the rails. That should have been a separate answer. I'm sorry.
That's totally fine. It was very concise. I mean, I'll be perfectly honest. I'm really proud. Usually, pop mining questions go a little longer, so that was great.
Oh, I still got some more, so we'll.
Oh yeah, yeah, we're not done yet, buddy. All right. Why is SegWit not supported for pop mining? With the TX in witness field, the second item is the public key, in parentheses, for P2WPKH, which sounds like a droid from Star Wars that Mattel made a figure of that no one purchased.
I also know exactly who this question came from. It's Pictatio in the audience right now. Good question. We are going to support SegWit at some point. You are right that data witness public key hash transactions do reveal the public key as part of the witness data. One of the original problems and why we didn't implement POP using SegWit, it was just simpler to get off the ground with the legacy approach, despite being a little less efficient for Bitcoin block space consumption. But the other part was for TapScript addresses, even if you're using a standard way of building those addresses where there would be a public key revealed in a witness, it's also possible to construct and do SegWit style transactions that are of a different format. And so we thought, there could be issues where users use some non-standard format. The current version of legacy addresses that we use, the only way that you can use those is in a transaction that ends up revealing your public key. So there's no way for people to mess it up. Whereas with SegWit, it is possible to do non-standard stuff and not have that public key revealed in the right place for POP payouts. But as I mentioned, with the higher data requirements in the future for POP publications post-sequencer decentralization, that new larger payload is basically going to necessitate commit reveals with TypeScript anyway. And so at that point, if not sooner, at that point, we'd definitely add support and move support over to only being used with TypeScript style address constructions.
Well, I do want to add there that we do reuse the keys both between Ethereum and Bitcoin, right?
Yeah, although with TypeScript, I believe you'd be, or with Segwit rather, I believe you'd still be able to do that as long as actually no, because those would be. I have to double check. Yeah, there is.
I don't think it's possible, actually. Honestly, I think we are going to have to reinvent POP payouts to do that. I think we've gone back and
you're right,
forth on
because I
this.
think I remember chatting to this a long time ago. Yeah, so actually with Segwit, the public key you're revealing, it's not the same format that you can reuse on Ethereum. So that's what we're gonna have to build for that is like a registration system where you register your address and associate it with an EVM address on the Hemi network for payouts, and then whenever HVM detects that you did a POP transaction from that address, from that script hash, then it would look up your EVM address that you registered on L2 to perform the payouts. Yeah, I forgot about the different key format. You're right.
Yeah, that was a big deal. That's why we actually stuck with that. And if I recall, if I rewind my brain, I don't know, a year or two ago, we were going to do pay to script hash, if I recall correctly, initially, and that was just not going to work out. And then we looked at that route, and it was also not going to work out. And it would also set us back quite a bit because there was a lot of crypto work that needed to be done and validated. So the other one we basically got, quote unquote, for free.
Yep, yeah, the legacy was easy to implement. It was directly compatible with Ethereum public key formats. So yeah, I think Marco is definitely correct on that. The public key format revealed in even a standard TypeScript is not a format that can be translated to Ethereum. That'd be using Schnorr signatures. The other thing with Schnorr too is if you're writing a wallet that can generate Schnorr signatures and sign Bitcoin transactions with them, you have to be a lot more careful because Schnorr has an issue with nonce reuse. And so with ECDSA, you don't have this issue. With BLS, you don't have this issue. But with Schnorr specifically, if you accidentally sign two different messages with the same signing nonce, that leaks your private key and it can be extracted. And so there's part of the extra cryptography work Mark was talking about. That's part of that is making sure that you build a system that securely calculates and either tracks the nonces you used or make sure you have an algorithm that is going to always generate random nonces with an infinitesimally small chance of collision. Which in and of itself is not a hard thing, but that's just one more piece you have to think about when implementing stuff with Segwit and TypeScript.
You faked me out on that last one. I was literally about to say, okay, thank you. No. Okay, if you guys want to keep going.
I thought I was done too, and then my mouth kept running.
That's totally
Yeah, but this is also
sir.
one of those things that are very simple on paper, but suddenly it's 2 months later, right? I think we've all seen this movie before.
Yep. It sounds simple, and then you go to actually write it, and there's 18 edge cases to think about, and a whole list of things you got to add to the test suite. So simple but not easy is a common theme in blockchain.
It's a great question, though. All right, here's one. Why does it take more than a day to tunnel ETH from Hemi to Ethereum mainnet?
Good question. So the comparative is actually on a lot of other similar chain architectures like Optimism. It actually takes 7 days. So with between proof of proof and some of the other stuff that we're working on designing, we're able to shorten that window. Once we get to ZK provability, that window will become even tighter. We'll probably be able to reduce that down to the 1 to 2 hour mark. Really, the long pole in the tent once we get ZK provability working is the time it takes to coordinate people constructing the ZK proofs and publishing them to Ethereum. So that will get shorter in the future, but it's right now a limitation of the Optimism style architecture chains with the current settlement mechanism they're designed to work with.
Okay. In the interest of time, and for the fact that I've been given the wrap it up sign a couple times. I have one more question for now, but we are definitely going to have to do a sequel because we have about 19 questions on deck still. So thank you all for joining us. The turnout's been great. The questions have been excellent. And we're definitely going to have to do these a lot more often because there's certainly demand. However, for the final question, bear with me. I'm going to do my best to get through this. For the Bitcoin security as a service vision, what is the planned technical integration path for an L3 team? And will Hemi provide a standardized permissionless SDK or rollup stack similar to Optimism's OP stack that would allow teams to easily deploy their own L3 that settles to Hemi? Or is it a more bespoke, partnership-driven integration process?
Great question. So, actually, great couple of questions. So, if you think of it visually, you can think of Hemi pop securing to Bitcoin itself, and then L3s pop securing to Hemi. And then you could extend that. You could have L4s that pop secure to L3s. And so you get kind of this tree of security inheritance. And at the center point of that is Hemi acting as a security aggregation layer. And so what that means is if you pop publish, states from 100 different L3s to the Hemi network, and then Hemi pop publishes just its own state to Bitcoin, that state of Hemi that's getting published to Bitcoin contains by proxy all the states of those L3s. So the L3s inherit L3s, L4s, L5s, whatever, inheriting pop security through Hemi. They all go through this aggregation layer, and no matter how many there are, how frequent they're doing pop publications to Hemi or the next chain, above or below them, depending on how you're looking at the stack, it doesn't change the cost of pop publishing Hemi state to Bitcoin. And so it's the reverse of what this question was asking of how would increasing L1 fees impact this. It's the reverse because now all of these chains together are collectively using their bidding power to pay for a fixed set of data publications to Bitcoin, regardless of the size of that tree of chains. And so if Bitcoin L1 fees explode in the future, then going to Bitcoin directly would be prohibitively expensive. But Hemi's security budget plus the pop security budgets of all these chains that are contributing through that aggregation layer, those have collective bidding power for that same block space that normally just a single chain securing itself with pop to Bitcoin would require. As for the tooling and software and integrations, as part of Chain Builder, we are going to have default reference implementations of L3s that you can just spin up on Hemi without modification. So the first version of that will just be a Control-C, Control-V clone of Hemi. Obviously, there's a couple of tweaks you got to make for it to work as an L3. You're swapping out the underlying EVM side settlement from being Ethereum to being the Hemi EVM itself, Hemi HVM. And then also, you can still have HVM running with Bitcoin state, or for chains that don't need HVM Bitcoin awareness, you'd be able to disable the HVM precompiles and the embedded TBC full node, and you could still get access to Bitcoin assets tunneled to Ethereum through the Hemi's Bitcoin tunnel. So different chains will be able to customize, which of those features they need, how much they want to pay for pop, what frequency of publications they want. And when you do have that multi-tiered pop publication, you end up getting different levels of pop finality. So you basically get initially Hemi publication finality, which means that as long as Hemi itself does not reorg, then the L3 is also safe from reorging. And then shortly after that, you get the full Bitcoin finality. So with Hemi, there's just, you either don't have Bitcoin finality or you do have it, because it's only pop publishing to one chain, and that's the end of that publication chain. But when you implement pop in a multi-chain tiered architecture, then you have those intermediate finalities as well. So you'd be able to say, this L3 is secure as long as Hemi's built-in proof-of-stake consensus protocol doesn't experience a reorg. And then shortly after that, okay, now we have full Bitcoin finality. So it gives more of a gradient of finality choices to the L3s, depending on what specific DApps or users of that L3 are doing and what their security profile is based on. So for example, people on Hemi, can choose, do I want to wait just for it to be confirmed in one Hemi block? Do I want to wait until it is in a Hemi block that's been published to Ethereum DA and that publication to Ethereum has been finalized by Ethereum consensus? or do I want to wait all the way for Bitcoin finality? And so the L3s will add an additional layer of confirmed on the L3, then secure with Hemi's own proof of stake consensus protocol, then secured with publications of that Hemi data to Ethereum for DA that got finalized by Ethereum consensus, and then finally Bitcoin finality. But yeah, so that we'll have reference implementations. Obviously, at first we'll start with one, and then we can expand that as there's interest in doing other stuff. You know, if there's tons of demand for an SVM running as a Hemi L3, we can build that, or a community member can build that and maintain it for a bounty. Because it is permissionless, you just have to integrate with the technology correctly. Anyone can build it as long as you understand how the pieces fit together.